Hello everyone, welcome to my YouTube video. This is Dr. Song. We were studying about the quantitative research method course regarding the JET scores. So last time I was explaining as much as I can about the JET scores so that you understood maybe the JET scores more, I hope. So this time I want to explain about the confidence interval. You can see here I put some notes. So that scores and then the p-value. That is a relationship between the two is very close. So that score means that in fact when you see the data distribution, and this is the like mean value, yeah, it's the average value. And then I was explaining that Z score means that how the individual scores are situated in in this distribution. So if the one score is situated here, let's say that is about there is about the 98%. That is the this score, and then we can consider that that is a jet score. The value will be the 1.96. Okay, so that score means that that is exactly, you can imagine the individual score, how they fall in the data distribution. So that is a jet score. Now p value is about the after the jet score, where this fall down, the which remains. So let's say that that is the 95% of the zone. There is 95% of zone, because from the here and then here like this, that is a 95% zone. So that is a z-score is a 1.96, which means that this is a 2.5%, and then the other part is a 2.5%. So when you add the 2.5, 2.5 is a 5%. So the two tails, you can consider that two tails, 95% means that is a 0.05. So this is a p-value. So you can see now how the z-scores and the p-value are closely related. So z-scores is inside of that data distribution, that indication of how they situated. And then when you identify the z-score, you can find also the p-value that is the outside of your z-score range. So that is about explaining explanation about the z-scores and the p-value. So when you have the z-score 1.66, means that that is about your distribution is about 90%. Okay, 90%. This means that this part is that part is the 5%, and then the other part is a 5%. So 5 plus 5 is 10. So the 90%, and then that becomes the 0.1. That's the p-value. Likewise, 1.96 means that I said already 98% here, so there is a range of 95%. 2.5, 2.5 is a 5%, so 0.05, and then etc. That is a extremely close to the almost 100%. That is 99%. Okay, so this is about the relationship between the Z and the p-value. Now, let's see about the confidence intervals. So what is that? In fact, the meaning is that to understand easily about this concept, we can say it's like a mean value is here, yeah, and then this mean value is not absolute. You should give the some error, like a margin of error. So for instance, the error is about this amount, error is about this amount. So let's say the like error bar, like that. And then you can say that not only the mean value is let's say the 50, but if it's a 52, and then this is a 48, we will consider that between the 48 and 52, it's the same, it's the same with the mean value. So this is the margin of error. So a bit error, we consider that that is the same, equal. So that is a confidence interval. That is the concept of confidence interval. And then how you can calculate this, you can see that the mean value, this is the mean value, and then plus minus, now it's a z-score. It depends on how much percent you want to give. That is a 90% confidence interval, and this is a 95% confidence interval, and this is a 99%. Each time when you multiply the standard error, so you can see standard error you can obtain by that. So the is your so the size of the sample, and then that is a root, square root, and then your the standard deviation is in the upside. So this is the standard error. So when you multiply the standard error with the how much percent you want to give as a z-score, and you can obtain the your margin of error. So the whenever you increased your percentage from the 90, 95, 99%, your this error bar will be the bigger. Okay, that will be longer. And then if you do the only 90%, your error bar will be the less. Okay, so that is like a common sense, because you give the less probability, and then of course the margin will be the smaller. But if you give the greater probability, of course that the margin will be the greater. So you will consider maybe not the between the 50 to 50, it will be the like a 54, and then it will be the 46. Yeah, so 46. So that will be the 99%. So this is a kind of approximate calculation. I just want to tell you that whenever you increase your p-value, it's the more exact possibility, and then your margin of error will be greater. So that is I want to tell you. Now let's see the real practice. So, how many adults live in an average Canadian household? You have here the average is 2.5, 2.46, and then you have the standard deviation, and then the total participants. So that is the formula how you can obtain the standard error will be the 11486, and then that will be the root, square root, and then that is that is in the bottom, and then that will divide by this standard deviation 1.398, and you will obtain the standard error. Now, that is simply you can put this formula. Your average is 2.56, and then plus minus 2. That means that is the 95%. Yeah, why? Because it's a 1.96. So that is approximately is a 2. So 2, and then you will obtain that. That is between 2.43 and 2.49. So this, if I want to make a kind of image, you will say this is a 2.46, that is the average. And then the upper part will be the 2.49, and then the lower part will be the 2.43. So we will consider that this range is the same, like a 2.46 is a mean. That is the margin of error. We consider that they are the same. This is also you can see that that is the yeah, let me see here, is it not the same? Yeah, it's not the same. So what did the average Canadian think of the maximum Bernier in the last election? Okay, that is about the political question. And then you have here the X is a 19.84 here, and then the still is a 95% confidence. And then you put the whole number of the participants here with the root, and then 27.444, that is up, and then you obtain this and that. So it's a 19.3 and then 20.4. So let's say that if the average is here is a 19.84, and then you will consider that is a 19.3, and then here is up is a 20.4. This area is the same. Yeah, we don't consider there is a higher and the lower, but they will be considered as the same. So that is about the margin of error. So confidence interval for the proportions. So that is about when you have the not the continuous variable, but you have the nominal or the ordinal variable. At the time, how you can obtain confidence interval. So this is a bit different formula. So you can see that the variable is like a liberal, NDP, and other. It's not a continuous variable. It's not a numerical value. In that case, you can go for this formula. So that is that you will obtain the valid value plus minus and the z. That is, it depends on the how much you put, 90%, 95%, 99%, and then you will obtain the still standard error. But this time, when the variable is now a nominal variable, your standard error will be obtained in a different way. So you can see here, So the total participants minus 1, that is in the bottom. And then the P means that proportion in the sample. You will see what that means, the valid percent. And then that N minus that P. So, and then you make the root for the whole, and that is a standard error. So let's see what that means. So you can see the valid percent is a 28.5. So that is you can put the as a P. So P is like a P is here, this one proportion will be the P is there, and then plus minus 2, that is about the 95%. Yeah, I already said. And then about the standard error, how you calculate, then you can see the total number is 733. You put that in the minus 1. And then the valid percent is 0.285. You can make that is like a fraction, and then a decimal point, and then you will multiply by 1 minus 0.285, and then you will obtain the standard error is this. Now you can just put that in the formula, you can obtain that. So that is about the 27.1%, and then 29.3%. So that percent means that is like even though 28.5 is average percent, between those two percentage, you will consider they are the same because there is a margin of error. So here again, the valid percent is this, and standard deviation is this. And then if we want to do the 90%, in that case, you will put instead of 2, 1.64, and then you can obtain that this is the margin of error, and then that becomes a bit smaller margin of error. And then if we want to put the 99%, that becomes the greater margin of error, because the error bar will be the greater. When it's a 90, is something like that, and then 95 will be the a bit longer, and then it's the most longer when it becomes the 99%, because your margin of error will be bigger. So that is like you can imagine that is logically. So, what if the sample consists of the 100 respondents, and then okay, you can just change that with the 100, and then it's the same formula you can obtain, and then there is 95% is a 2, yeah, and then oh sorry, and then if there is a changing the 100,000 respondents, and you can put the same the formula, and then you can obtain that as a still 95%. So this is the how you can obtain when the variables are the nominal variables. Okay, so you can see here about the one practice, and then you can see the standard error you obtain is that. So that is the standard error of the p valid percent, and then that divided by the whole number and the minus 1, and then you can obtain this one, yeah, like that, because there is 95%, and then this one, and then that is a between 0.52, 0.58. So that is like a margin of error. And then even though your mean value is 0.55, but between the 0.52, 0.58, that will be considered as the same. That is about the concept of a margin of error. Okay, so thank you so much for watching this video about the confidence interval. And then we will continue next session with some more details. And then we can also start our lab. So this will be the week of 3 and the 4 session in the quantitative research method. Thank you so much, and see you next time.